All right, so let's revisit the mean because the mean plays such a central role in statistics. So let's revisit it. So here's an example. Suppose we want to find the mean of these numbers. Let's say 1, 1, 1, 1, 5, 5, 10, 10, 10, and 25. Okay, so what do? First of all, we count out how many of them we have, and we've got 10 of them. So we've got 10 numbers. What do we do then? Well, we total them. So let's see, 4 plus 14, 24, 34, 44, 69. So the mean is 69 over 10. So that's 6.9. And there it is. Fine. So my arithmetic is good, and I'm sure your arithmetic would be terrific to calculate this also. Alternatively, I could count the other way. I could say 25 plus 10 plus 10 plus 10, etc. And hopefully I would get back to 69. I want you to think of another way of summing this. Can you spot something? What have I done here? I've made a number of these things equal to each other. So can we take advantage of that? Well, okay, there are, let's see, there's 4 1s, there's 2 5s, there's 3 10s, and there's 25. So how could we total that? We could say, well, 4 times 1 plus 5 times 5 plus 2 times 5, 2 times 5, 2 times 5, 3 times 10, and 1 times 25. And we would get the same number. We would get the same 69 if we did that. And then if we're going to now get the mean of that, we have to divide by 10. Now, I could divide the total by 10, or I could go into these things and divide each one of these by 10. So 10, 10, 10. And let me rewrite it in decimals. So what do I have is I have 0.4 times 1 plus 0.2 times 5 plus 0.3 times 10 plus 0.1 times 25. And that is my 6.9. Okay, I haven't changed anything, so there's 6.9. Now, if I'm a mathematician, I'll say, oh, look at this. This is a general formula. What have we done? This is the proportion. So that's the proportion of ones. So let me call it P1. That's the first proportion, and it's 0.4. This is the proportion of 5s, which is 20%. So let's call that P2. This is the proportion of 10s, which is P3, and this is the proportion of 25. So that's P4. All right? So I can rewrite this, if I like mathematical notation, as summation. J goes from 1 to 4 because we've got 4 groups. P sub j times what? Well, the first time is times 1, then it's times 5, then it's times 10, then it's times 25. So let's call that x sub bar j, which is the typical value in that particular group. So we see that the overall mean, let's call that x bar, can be written as a summation of proportions times typical value. Okay, now what if, on the other hand, so what if not all the x's are equal in a particular group? Does that make any difference? Can we still do the grouping? And the answer is yes. Let's just do it by example. Okay, so suppose that the numbers I have are, let's say 1, 2, 3, 4, 6, 8. So there are my numbers. Now I'm down to 6 of them. And suppose I'm going to group these 3. And suppose I then group those 2. And then I'll group this one by itself. Okay? So now, what is the sum of these? Well, the sum of these is 6. Divide that by 3, because there's 3 numbers, so that'll give me the mean of them. But if I want to keep the arithmetic the same, I have to multiply by 3. So here I've got 2, and so their sum is 10. Their average would be 10 over 5, but then to retain the summation, I've got to multiply by 2, and the same thing here. So 1 times 8 over 1. So once again, if I want the mean, I've got 6 numbers, so I need to divide the sum by 6. So that would give me the mean. So now I have to divide this by 6. So let me bring that in there. And now what do I have? I've got the proportion for the first, and that's 3 over 6, so that's 50%, so it's 0.5. And what is the average of them? X bar 1 would be 2, plus the proportion in the second group, so that would be 2 over 6, which is 1/3, which is, let's say, 0.33, and times 5. And then plus 1/6 would be the P3, and now that's equal to 0.167, let's say. And then that's times 8. So once again, I can write this as summation Pj x bar j. So x bar 1 is 2, x bar 2 is 5, x bar 3 is 8. So this is from j equals 1 to 3. So this is exactly the same form as we had before, namely the overall mean x bar is a weighted sum of these xj's. All these weights have to do is they have to sum up to 1. And secondly, each one of the pj's has to be greater than or equal to 0. And that's it. Okay, so let's see where we might find some use for this. For example, suppose I've got a hospital. And so I've got a hospital, and what I want to do is I want to find out what the mortality rate is for my hospital, so that if I am looking for a hospital, I might look at the hospitals and see which is the hospital with the lowest mortality rate. And I might think, oh, okay, that's the best hospital. That's where I'd like to go if I have to go to the hospital. Let's simplify the argument and say that there are 3 groups of people who go into the hospital. Let's say there's the young group, and let's say then there's the middle-aged or middle group. They're not middle-aged. And then let's say older folks. So those are the 3. Now, let's just for argument's sake say that the mortality rate associated with the young folks is something like 2 per what? 1,000, 10,000, whatever it is. Let's say 2 per 1,000. Middle group, let's say, is 5 per 1,000. And let's say for the older group is 8 per 1,000. Okay? Now, going back to our formula for our hospital. Suppose we've got a hospital, call it Hospital A, let's say. And let's say in Hospital A, 50%. So let's say 50% of the folks coming into Hospital A are young folks. So what is their mortality? It would be 50% times 2. And let's say that the middle group, there were 33% in the middle group. And so the mortality would be 5. And the last group would be, it has to add up to 1, so this would be 17%. And that's at the 8. All right? So here's our formula from before. We had the proportion times the mean for that group. Proportion times the mean for that group. Proportion times the mean for that group. So that if we calculate the average, namely do the calculation here, we get that the answer is 4. I actually chose the numbers so that the answer would be 4. Okay, so the average then would be 4. And our units are per 1,000, so it would be 4 per 1,000. So there's our average for Hospital A that accepts this percentage distribution. Okay. Now, what I want you to do is go off and think about this for yourself a little bit and see what happens when you have a hospital with different percentages, with a different mixture of patients. Always the same. Keep these the same. So arguably, these hospitals that you're going to be playing with will have the same or comparable mortality rates associated with the 3 age groups. But all I want you to do is play with these and see what happens to the overall average. And then come back to me and say, maybe I shouldn't be looking at the overall average when I'm rating the hospitals. I should be looking at something a little bit more subtle, a little bit more standardized.